Hello, my name is Caleb Short, and my subtopic is Automated Unit Testing. The paper covers understanding why automated unit test generation, or AUTG for short, is not widespread. For instance, the majority of effort in automation is making the automation functional as opposed to actually using it. Another example is a lack of a concrete understanding of what AUTG means. Then finally, there is, or at least at the time of writing, a lack of AUTG tools. Unit Test Bot, the solution proposed by the authors, is a tool for automatically generating unit tests. Why is this topic important? It helps to understand the discrepancy between research and industry in unit testing. Also, automation of testing is a useful concept. Creating Unit Test Bot focused around the core technology, KLEE, which is a symbolic execution engine. No KLEE-based tools were implemented into any IDEs at the time of writing, despite it being a mature and well-developed project. The researchers had three main tasks: automating setup, pre- and post-processing, implementing user-friendly UI, and improving performance of the KLEE engine. The result can be found at utbot.org, and it is available for C, C++, Java, Python, and several other languages. There's also a GitHub page. Just search for Unit Test Bot. The software is a ready-to-use product that automates unit test generation and creates human-readable tests. Why did I choose this paper? For starters, I hope to learn about the impacts, implications, and applications of automated unit testing. Furthermore, automation of testing is very relevant for Agile and DevOps SDLCs. Finally, I wanted to see how a user-friendly AUTG product could work in practice.
Hi, my name is Clayton MacArthur, and today I'll be talking about a survey of video game testing by Cristiano Poletsky, Fabio Perillo, and Yongul Gohek. This paper talks about the method game developers use to test their code bases. It also covers the possibility of automating video game testing. This topic is important because testing for video games compared to traditional testing for coding projects are quite unique. Often video games use gameplay testing instead of reviewing their code base. Many have speculated that it would be more efficient to use traditional testing methods. However, current game developers disagree. Bugs in video games are often very random and unpredictable. Would it be possible to automate video game testing? Current developers say it would be impractical to automate video game testing. There are three main reasons: incompatible across different games, inefficient time-wise, and nearly impossible to build a testing software. Since games are so different from each other, game developers say that a testing software would not be able to be used on different games except for the one it was created for. Game testers also often test their own code bases by playing the part/action of the game. Since developers are quick at discovering bugs, it would be less efficient to attempt to automate this. It also would be extremely difficult and expensive to develop a testing software. This is why most companies would not expend resources to create one. How can this be used in practice? Creating efficient unit testing for gameplay testers. Developing strategies for game developers and game testers to effectively communicate, maximize productivity, and possibly creating an automated unit test bot for specific parts of the game that could be transferable to other games. Why this paper? I wanted to learn more about the unique unit testing for video game testing. I wanted to understand how unit testing is used and adapted to different code bases and programs, and I wanted to learn how to implement unit testing in unique ways into my own program and game development. It is also important to remember that it may be possible to automate certain parts of the gameplay, like maybe the menu or different aspects like that of the game, but generally speaking, it is nearly impossible to automate unit testing for games.
Hello, I'm Cody Nigg, and my paper is an industrial evaluation of unit test generation, finding real faults in a financial application. So my paper evaluates the effectiveness of automated test generation tools EvoSuite and Randoop on industrial financial application LifeCalc. My paper also identifies strengths and challenges in detecting different levels of software faults with the automated test tools. It includes a survey of 5 different developers who worked on LifeCalc and their thoughts on the usefulness of automated test results as well. This topic is important because effective automated tools can help us save time and effort when we're testing our softwares. These tools can identify faults that are overlooked by user testing, Automated testing can also offer consistency in software tests. We can use the results found in the paper to improve test generation tools to handle complex softwares better in the future. We can also encourage the use of these automated tools to improve company efficiencies. Going into this paper, I was hoping to understand the ways that automated testing can help improve software quality. I also wanted to understand the limitations of using only automated testing for software compared to manual testing. And I was curious of professional opinions on the usefulness of automated testing versus manual. I do agree with the viewpoint of this paper. Automated testing does have real advantages to manual testing, and when it works well, it really improves speed of testing compared to having to create a manual unit test for each program. I also feel that automated testing is currently limited and cannot be trusted for a full test of any professional software products, as it just misses too many faults. Limitations of this paper: there were only 2 automated tools that were tested in this study. There's a lot more, including different random testing tools, search-based testing tools, and others. The paper only tested for 25 known faults, which this number could be far larger to improve this study. The results may be different for other applications or languages as well, as this was ran in Java. I do think this study is really important and something that should be improved in the future and expanded on.
Hi, my name is Max MacArthur. I'm part of Team 2, the Programming People. My paper was on evaluating software quality in agile environments. First off, a paper overview and what I was hoping to learn from the paper. This paper discusses a survey that was conducted with various types of software professionals. The survey is about unit testing and the exposure that different professionals get to unit testing, especially in agile environments. I was hoping to learn more about unit testing and its importance in the software field. Why is this paper subtopic important? Unit testing is very important to the development of all software. Unfortunately, as this paper discovers, unit testing falls solely on developers, and other software professions have little to no knowledge of how unit testing works. Unit testing is becoming more precedent as software development progresses, especially with new types of agile SDLCs. Unit testing must occur throughout the development process, and not just at the end of the project. How can this study be used in practice? This study will help in the future when it comes to agile unit testing development. Paper stated, our findings pave the way for future research as numerous aspects of software testing and test automation in agile development could benefit from a similar investigation. The results of this study are generalizable to all different aspects of unit testing in the software field. Is the conclusion that this paper comes to logical? The conclusion that this paper comes to is that if we can take certain testing and quality processes and incorporate them into all the software professions, then the development of software will become a smoother, more efficient process. By making every stage of software development have foundational understanding of unit testing, all software produced will be more